time. All right, welcome. I'm Michael Ducy. I work on the Falco project, which is a CNCF sandbox project. And today I'm going to talk about a little bit of a deep dive of how we extended Falco to support other event sources. Who is familiar with Falco or have played around with it at all? Great, that's good to, and my job is working. Okay, so a little bit about me. I do everything open source at Sysdig. I do a little bit of engineering work. I do advocacy work. I help with the legal side of things. Basically all the open source stuff that nobody else wants to do that isn't directly engineering work. You can reach me on Twitter or on GitHub at those handles. In the past, I used to work for Chef, so I have a background in open source and have been mainly a consumer of open source for about 20 some odd years, and used to work at Orbitz Worldwide a long time ago and cut my teeth in the operations space there. So this is the slide that everyone wants, and most people wait until the end to show this slide. So I figured I'd put it up there and you can take a picture of it real quick, and then you can follow those links. Well, it's hard to do on a picture, right? One day we'll figure out a better way to do this. So go ahead and grab that real quick. One thing I'll point out is there's this Falco security workshop, which is a workshop with slides that you can actually do on your own. There's 4 exercises that show you how to set up Falco in a couple different scenarios, use Falco with things like Elasticsearch and Kibana and FluentD, use Falco with things like Lambda functions, SNS, NATs, kubeless, and other cool things like that as well. And I'll have this at the end as well. So if you miss it, you'll get to see it again. This is the Falco team. So if you interact with us on GitHub, just to put a face to the name or a face to the handle, Leonardo and Lorenzo are actually 2 Falco engineers that we recently hired and joined Sysdig at the beginning of May. And I'm really excited about that because we now have much more dedicated engineering resources to put into the project, and we have a lot of great things planned for the project. Mark is one of our engineers that have worked on the project since its inception. Loris is, of course, our CTO at Sysdig. And then everyone just refers to me by my last name, so feel free to, or Michael. We are looking at doing a lot of things on our roadmap, so I wanted to kind of put this out at the beginning. If you're interested in finding an open source project to contribute to, we have a lot of work that we are planning to do over the next several months, and we would love other expertise, other opinions. So I think that's one of the great things about open source is where we can actually go and get other points of view, and then we can bring those in and build an amazing project or product with it. One couple things I'll point out is the profiles library. So we want to expand the rule sets that people can use with Falco so they can get more value out of Falco more quickly, especially compliance use cases around PCI and SOX and HIPAA and all the GDPR and all the regulatory things that us technical people have to worry about. And then a couple cool things that we're planning, the Prometheus metrics exporter. So if you are familiar with how to write metrics exporters for Prometheus, this is a great thing to help out on. And then also gRPC-based outputs, so more of a streaming-based outputs to make the output framework a little bit more flexible in the Falco engine. There's also some other things like our Helm chart, which is part of the Helm repository. And then also a Kubernetes operator as well. So if you're looking at getting into the operator space and looking for a project that needs help around an operator, this might be a good place for you as well. And then new event sources. So what I'm going to talk about today is how we extended Falco to provide this kind of generic interface in our code base to where we could then go and easily add in new event sources that we can read from. I will say the language is written in C++ and Lua. So if you were looking for a great C++ project or Lua project, you found one. One other thing I'll add to that is that's one of the reasons why we're looking at doing the gRPC-based outputs, is that so we can build a more plug-in model for any of the outputs where you want to send your alerts to. And those outputs could then be written in another language like Go or Rust or whatever you would want to use or prefer to use. And then you just read from that gRPC stream the events that Falco is alerting on. So what is Falco? Just to recap for those of you who don't know what Falco is, it's a behavioral activity monitor. Those are fancy marketing words. From a technology perspective, just think of it as another host intrusion detection system. It's different than audit D and some of the other auditing frameworks that have been out there, mainly around the language that we use to build our rules. And also, we have full support for containers and orchestrators as well. So we can pull in that metadata. We can find out information about where the process is running inside of which container, inside of which pod, underneath which service, underneath which namespace in Kubernetes. The other nice thing is that you can use that metadata that we pull from the container runtime to actually go and write your rules as well. You can send notifications to a variety of different locations, so file, standard out, syslog, programs, HTTP endpoints as well. And this is where, as I said before, that we're trying to expand out the different places that we can publish our alerts to. And as I've already said, it's open source, so anyone can contribute rules or improvements to the underlying engine. And I've already said this as well, so I'll skip through this. We are a sandbox project. So let me just give a quick demo of something, and then we'll get into the Falco parts, and then I'll jump back and give you a demo of Falco itself, or at least of the Kubernetes audit events. So let me switch over here, and I'm just going to run okay, so for whatever reason, my history never saves on this machine. So I'm going to run Sysdig, and I'm going to talk to the Kubernetes server I have running. And I just need to pass in some credentials. So just give me a minute. That's why I wanted to be able to use the command I ran earlier. Cert, and to make this faster. All right, so this is Sysdig. This is one of our other open source projects, and I like to show it because it shows what you can actually see with the Falco kernel module probe or eBPF probe that we use. So Sysdig uses the exact same module or probe, and we can pull back everything that's running on the system. So we can see here on this machine, which is just an AWS instance, all the different services that are running. So this is the processes view, and this isn't extremely useful because we don't get any context. So let's add some context. So the first thing I'm going to do is let's go and look at what namespaces I have running. And so I can see that I've got I have things running in two different namespaces, the default namespace and the kubesystem namespace. I could also look at this from a different way. Let me go and look at the services that are running. So I have the kubedns service. And the awesome thing that I like about this is that it aggregates. So we see the file activity and the network activity. And we're getting an aggregation of all the pods that are running on this node that back that particular service. So this is per node. So it doesn't look at the entire cluster and aggregate all that data back yet. So I can then go into that service, and now I see the actual pods that are backing that service. And then I could say, well, let me go into this particular pod, and now we're looking at the containers. I could go in one step further, and now I'm actually seeing the processes that are running inside of that container. So I'm able to drill down very easily into actually what's running in the system. So I'm going to go back, and you just hit backspace to do that. And then I'm going to go into the default namespace. And in default, I just have an Nginx deployment running. And I'm going to just go and look at that container. I could actually just go back one step. So I'm in the namespace. If I go in one more, I'm in the pod, or I'm looking at the containers. And I'm in that pod. And so now what I want to do is I want to do an F5, and I'm going to echo. And so let me just switch over here. And I'm just going to do a kubectl describe pods. Grab this IP address, and I'm just going to curl that IP address. And I got the Nginx welcome page, which is what we expect, but that's not the awesome part. The awesome part is over here. So you can see that I'm echoing I/O activity for this particular container. And what I can see is I can see the actual raw Git come in, and then I also see the server's response, right? So this is how at a very, very deep level we can understand and see what's going on the system. And then this is the basis of Falco, that we use this particular tap to actually pull back all of this information and then write rules around this information. The other thing I want to point out is up at the top, you can actually see the filters that we're putting in place to actually filter this data out. So if I go back to let me just quit and then restart this. If I go back to the original view, let's actually go and look at the kubelet. So now I'm looking at all the threads the kubelet is running, and you can see at the top I'm filtering on proc PID, and I'm pulling back that particular PID. And then I can actually do something else. I want to see all the system calls that this is running, and I can see all the different system calls that are happening for the kubelet. So what is it doing right now? Can anyone guess? It's just waiting, yeah. It's just waiting to get some sort of an activity for somebody to tell it to do something. And then the other thing is you see that filter where we're filtering out like context switching and other things as well. So that's useful to understand how filters work. And Sysdig is a great tool to help you understand how filters work if you're going to be writing rules for Falco. All right, so let me jump into how Falco works from an internal perspective. So we have the kernel module that we had talked about, and this basically sends in those system call events. And that's what we're actually looking at, is this stream of system calls that are going through and going into the engine. We then have rules, and the rules basically use that filter expression syntax that I showed earlier, that event.type does not equal switch. So you would do things like event.type equals write, or event.type equals open, or accept for accepting a network connection, and so forth. And so when you apply those rules, then we can filter that out, and anything that matches your rules, you can then send an alert to say somebody did something on a host. So the most basic example is somebody spawned a shell inside of a container, right? So anytime somebody spawns a shell inside of a container, if you have Falco running on that particular node, you'll get an alert within a matter of milliseconds that event happened. So this is another example of a rule. So we use, here we have event.type equals open and fd directory in bin user sbin. And then what will happen is we'll get an alert that anytime somebody does any opens to anything underneath those directories, we would get an alert. Now, this is actually a bad rule because it's actually truncated. We should have another thing here as well. What will happen with this rule? Can anyone guess? Anytime you use anything under bin or sbin, you're going to get this rule to fire. So this rule has actually been truncated by Mark, who originally wrote this slide. So this is a bad example of a rule. But it gives you an idea of what a rule looks like. The other interesting thing is you have this output. So this is the actual alert that we would fire or publish. And then you have the % username, % proc command line, and % fd name. This will actually get replaced with those fields from the system call event that you're filtering on, right? So you'd actually get the username, the whole command line that they ran, and then the file that they manipulated as well. So what happens here inside of the engine is that we extract all of these values using these filter fields. So we have the system call event, and we say we want event.type, and then anytime that we see a system call event with open, that goes into the rules engine. Same thing with fd directory. Anytime we see in that syscall event bin or user sbin, then that gives a match to the rule engine. And then the same thing with username. That filter field gets extracted as well. Same thing with command line and the file name as well. So all of those basically pull from that system call event a particular value. So we wanted to figure out how we could extend Falco to work with other kinds of events and other event sources. So Falco isn't necessarily a replacement for Logstash or FluentD. What it is a good way to put event markers in that giant stream of data that those logging platforms are collecting for you, right? So you want to put markers around things that you deem interesting. And then when you actually have to go back and look at those logs, you actually have those event markers that you can start to key on, that somebody spawned a shell inside of a container, and then all of a sudden we see a bunch of logging with a bunch of errors or something like that. What you would want to do is filter on that terminal shell in a container, and then you can look at that in context with all of your other logs to understand that it might have been that person who spawned a shell in a container, why all of a sudden we start having network connection failures because somebody started to do a port scan or something like that. So we extended Falco to support Kubernetes audit events. It's a new feature in Kubernetes 1.11. And what it does is it provides this chronological set of records documenting changes to the cluster. So in layman's terms, anytime somebody does something through the Kube API server, an audit event will get triggered. This can go into a log file. You can also tell it to go into a webhook as well. And each record is a JSON object, which I'll show you here in a second. And then there's something also called audit policy. And audit policy basically lets you set how noisy is that event stream. So do you want to log everything? Or maybe do you only want to log things where the response was, the request was successful, for instance. There's a new feature in 1.13, Kubernetes 1.13. It's an alpha feature, and it's called audit syncs. So the log file and webhook and even audit policy before 1.13 had to be configured on the master. And the problem with configuring it on the master is that if you're running in something like EKS or GKE or some other managed Kubernetes service, you don't get access to the master, and so therefore you can't drop files onto the master to configure the log file and webhook. Audit sync is a way to fix that to where you can actually apply a Kubernetes manifest via the API server, and you can configure audit policy that way. And by the way, it's sync, like you're pouring it down the sink, not SYNC. So this is what an audit event looks like. And so we can see here that we have the verb, so what was trying to be done. So this is kubectl, apply, delete, whatever you want to do. And then we have what we were trying to do that to, the actual URI of what you would hit on the API server. We have the user who tried to do it. We have the response code, whether if it was successful or not. And then we get the object reference as well. So we see the resource namespace, and the namespace was named foo. So the Minikube user deleted the namespace foo, right? And we see that the action was allowed. So we needed to figure out a way how we could get these events into the Falco engine, build rules around that, and essentially extend the rich Falco language that it already has, and then being able to alert on those particular events. So what we did is we embedded a small web server inside of Falco. And this web server is basically you are able to send the Kubernetes audit events using a webhook into this web server. And so all you have to do is you post to the Kubernetes audit event, or the KS audit endpoint of where Falco runs. And now we have two different types of events. So we have the system call event, and now we have the Kubernetes audit event. The nice thing is that this web server can actually be extended and used for other things. And so if we wanted to add in, or if you want to add in other event sources, then you just need to add in a new endpoint, and then that would basically create a new event that gets passed into the rules engine. And so what we did is we created in the code a generic event interface, essentially. And then any new events, therefore, would then inherit this generic interface. And then the generic event interface provides a couple things for you. So one, it records the event time for you of when that event actually was received by Falco. And then it gives you some primitives that you can use to actually extract the values out of that JSON document that's getting posted into the web server. So then we created a specific event for Kubernetes audit events. And then we've been able to define fields using something called JSON pointers, which I'll talk about here in just a second. So now, when you write Falco rules, you have to specify the event source. And so you can say event source being syscall or event source being Kate S audit. So let's talk about JSON pointers, of a feature that we use to pull that data out. And this is also useful because now you can actually extract any arbitrary values from that JSON document. So if Kubernetes audit events or the Kubernetes audit logging team decides to add in new fields to the JSON document, we're able to automatically support them through this use of JSON pointers. So a JSON pointer is essentially where you can reference using this kind of directory-based format. So /foo, if I specify /foo, then it would return 1. If I wanted to get the value of Baz, so I just specify bar/Baz, and I'll get T back. And then if you have an array or something like that, then you can just reference which element of the array that you want to pull back. And of course, in this case, we would get 4 back. So looking at that audit log event from Kubernetes, all we need to do is then be able to go and have a pointer into the verb, and we can get back delete. We have response status code, object ref resource, and so forth that we can easily pull back out of this document that Kubernetes sends to the Falco engine. So the way JSON pointers work is essentially in the language now, and I'll give you a deeper example of the language in just here in a second. We can now reference, instead of proc.name or proc.pid or fd.type and those sorts of things, we can now reference this raw object called jEvent.value and then use that JSON pointer to reference what we actually want to extract from that JSON document that we got in as an event. We create a whole bunch of ones for you. So we have defaults for verb, KAURI, username, target resource, etc. And those are all defined as macros in the Falco rules file. So let me walk you through an example, and then I can jump back into the demo real quick. So this is how you can use these rules. So we want to see anytime that somebody creates a config map containing a private credential. Now, you might feel that this example is a little contrived, and in some ways it feels a little contrived to me as well. But the thing you have to keep in mind is, like, sometimes when you start to approach security, you think you need to do all this, lots of different things, right? And you think that it's too hard. But a lot of times you just need to put security guardrails in place so people don't do dumb stuff. Because usually what happens is somebody left an S3 bucket open to the public, right? Because they just didn't apply the right rules. Or somebody stored credentials somewhere that they shouldn't have. Or they uploaded credentials to GitHub. Or they leaked their credentials somewhere else, and now somebody's holding their GitHub repositories for ransom, right? All those things happen all the time, and it's mainly just because somebody did something stupid, right? And it's not because they were malicious, right? So here's an example where we're defining first a macro. A macro is essentially just a shortcut to a condition. So I wanted to create a condition that basically says contains private credentials. So I just define a KA request config map object contains. So this is actually the raw data that's inside of the config map itself. So the Kubernetes API server will actually send that raw config map over to any of the event sources that are being used for auditing. And then I can define what a config map is. So I just say KA target resource equals config maps. And then I define modify, because in the Kubernetes API server, there's multiple ways that you can modify something. So we create a generic macro for modify that includes create, update, and patch. And then we have the actual rule itself. So all Falco rules will start with a name for the particular rule, a human readable description, and then we have our condition. So the macros make it really, really easy to write the condition. So I basically just say I'm a config map, and I'm being modified, and I contain private credentials. And anytime that we upload a config map with any of these keys in it, we'll have this fire off. So k8s config map with private credentials, we'll get the username, we'll get the verb, we'll get the config map name, and we will actually get the entire config map as well. Now, we don't actually remove any of that data. That actually would probably be a good thing on the help wanted slide. The nice thing, though, is because we'll, if somebody actually did this, we would put the private credential in the log, and then since the private credential is out there in the public, it's been leaked, and you'll need to rotate that key anyway, right? So we're helping you out. So let's do a quick demo of this, and then that should put us right up close to time, and I can take some questions. The beauty of a cellular connection. So the demo I'm going to do is actually just straight from the security workshop. And so let me just refresh my memory of what I need to do. All right. So when you run Falco in a Kubernetes cluster, we deploy as a daemon set. And then we store all the configuration in a config map. If you use the Helm chart, this actually takes care of all of this for you automatically. And then the Helm chart is, of course, parameterized very nicely, so you can turn features on and off very easily. So I'll create my config map. And then I just need to create my daemon set. All right. And then I'll just do a kubectl and show you that Falco is coming up and explain what's going on here. While we wait for that, I can change directories. There we go. So here we see an alert that a privileged container was started. And that's actually, I've never seen that before where like Falco catches itself starting up. That's actually interesting. And I've done this demo like probably 100 times. Okay, so we see that we've started up. We see that we built a kernel module. So we'll do that for you automatically. You can actually disable this. And this is actually one area that we have an issue open that we could use some help on. We need to build slim images that don't ship build tools, because that's bad for a security tool. And then we need to have the image that has the build tools in it that can automatically generate the kernel module for you. The nice thing is then you can copy that kernel module out, and you can present it via persistent storage, or you can have it available over an HTTP endpoint, and we can download the kernel module automatically for you as well. You can also use the eBPF probe, but you need to have a newer kernel, so 4.14 or higher, in order to do that. So we see that we'll build that kernel module for you automatically, and then you can also see that we've actually started Falco up, and you can see the rules that we're using and that the web server started up. So everything's working. So now I'm going to create that config map that we talked about earlier. So let me just make sure it doesn't exist. Yep, so I'll just do a kubectl, create config map. And then I'm going to do a couple other things real quick too. So I'm going to do a kubectl exec, and let's go into the Falco pod and let's get some other things to fire off. So I'm in the Falco container, and I'll just touch bin hello. And I'll exit real quick. And let's look at those logs again, and I'll explain what happened. So You see there's that warning that a config map was created. This, of course, came from the audit endpoint. And you can also then see that a shell was spawned inside of a container. And so what I like about this, especially as you think about event markers inside of your log so that you can actually do analysis about what happened after the fact when the container is no longer there, is that we see that a shell was spawned in a container. This actually came from the system call event. We actually saw that somebody opened a TTY in an interactive mode. They spawned bash, and they've gotten into the container. The other thing then we see shortly after that is that, notice, we attached exec to a pod. We got the user who attached to the pod and the actual pod that was attached to as well, the namespace and the command as well. And so now I have two events. And if I had that somebody went interactive, so that somebody spawned a shell in a container, and I didn't have that somebody attached exec to a pod, what does that tell me? That they didn't get in via the kubectl or kubectl exec, right, or through the API server. They got into that container in some other way. And so that's why it would be important to extend Falco out with more event sources like, for instance, the container runtime, and having events coming from the container runtime so that we can begin to build a more thoughtful audit trail. You also see then that we have the event that somebody tried to open a binary directory for writing. You also see the namespace name, the pod, and so forth. And this, basically this KS pod, this can be used to, you can use deployment, you can use labels, you can use the namespace name or ID or whatever you want. And so the nice thing is you can build rule sets that focus on a particular namespace or a particular application given the deployment's labels and other things like that as well. So you could have one rule set for maybe your PCI compliant namespace or your PCI compliant cluster, and then you can have a different set of rules for dev and staging and other lower environments as well. So just to put this slide back up for you. I'll just give you a quick rundown as well of the repository. So we have the website where the documentation is hosted. We have the operator and Falco as well. We also have a Kubernetes response engine, which will help you set up, basically the Falco alert will go to a pub subservice, and then you can have a function using a function as a service framework actually take action on that event. So it can kill the pod, it can taint a node, it can isolate a pod using network policy and a lot of other cool things. This is actually in the workshop. It's exercise 3, so if you want to stand that environment up. It works on AWS, it works on Google, using like PubSub or SNS and Lambdas. Or you can stand it up in your own cluster using NATs and kubeless. And then also the profiles, where we have some default rules that you can use for common applications. And let me just put up this last slide, and I'm happy to take some questions. And John has a microphone. John will run it around for us.
Is it possible to extend the audit events with extra parameters from, for example, Kubernetes, so that if something has changed, that you pull extra information from the cluster?
I don't believe so. What I would say you should do in that case is you would have Falco fire the event, and it goes into a pub sub service of some sort. And I've seen people actually do this. And then what they do is they have a Lambda that picks that event up, and then it queries the environment for more metadata that they want to add into that particular event, and they can expand that event out. Those Falco events can be in JSON format, and then you would have this JSON object, and then the Lambda can actually add more to that particular JSON object. But that's typically how that would be done, so you don't necessarily need to add that into the Falco engine.
Thank you.
Yeah. One question per row. Yeah.
Is there a chance to get it running without root rights, for example, for audit logs only?
With what?
Without root rights as a non-privileged mode.
Oh, it is not possible to run right now as non-privileged. We actually had, somebody brought it up the other day, or it was actually a question from another Falco talk. If we've tried to define the set of capabilities that the Falco container needs and having like a pod security policy with all the capabilities defined so that we don't have to run as a privileged container. It's something that has actually just come up. If you don't want to run as a privileged container and you want to add like a layer of isolation between your Kubernetes cluster and containers, you can actually install us directly on the node itself. So we publish RPM packages and you bake us into your base image, and then you can have that one additional layer of abstraction where you're running directly on the node's operating system.
Great, thank you.
Yeah.
Maybe it's obvious. What do I need to run Falco on a host? Do I need kernel modules? Do I need a certain kernel version?
We're pretty flexible on kernel version. We actually do support fairly older kernels, mainly because of RHEL 5 and older versions of CentOS that people still use. You really just need the kernel headers so that you can compile that module initially. But the features that we use for the kernel module came in like 2.628 or something like that, so a fairly old version. So if you're running any operating system within the last 3 or 4 years, we should support it.
Is it a built-in module or an external one?
It's an external module, yeah. We're not in upstream.
Okay, thanks.
Yeah.
And eBPF, you mentioned eBPF?
Yeah, you just need to set an environment variable to use the eBPF probe, and the probe loader will load it, will build it and load it automatically for you. So it's really just an environment variable, and we switch between the kernel module or eBPF probe. You do need a newer kernel, 4.14 or higher, and so unless you're on like, I think, Ubuntu 18.04 or a really, really new OS, it might not be useful. If you're using GKE and CAUS, the eBPF probe is the only way to get Falco to work.
And eBPF is optional?
eBPF is optional, yeah. You can do the kernel module or eBPF.
Okay, thanks.
Yeah.
Thank you.
One thing that we're also thinking is, can we just disable the kernel module and system calls so that you could just use this for the Kubernetes audit events, right? That's just a flag we need to add into the configuration and plumb that out.
Okay. Thanks for a great talk.
Yep, thank you. And we can probably do one more. I'm sure most people want to get to lunch.
Okay, real quick. If I've got a rule that a port scanner is not allowed on one machine, can Falco actually permit or disallow the execution, or just give an idea that a user did it?
Yeah, we just notify. So we don't block any of those operations. What you would do is you would have some other something that would pick up the alert and then try to do some sort of a blocking or stopping or whatnot. The response engine actually has a function that allows you to delete a container, and within a matter of milliseconds, the container will get deleted from the Falco alert getting published into the pub subsystem. It's actually pretty quick. And that's exercise 3, as I said, in the security workshop. Thank you very much. I'll be around if anyone has any additional questions.